Hi everyone, this is the video lesson for 5.5, the derivative of y equal to 10x. Now if you look at the warm-up, the first question says what is the derivative of y equal to 10x. Now you have to make sure you've done your homework and went through the lesson for 5.4 before answering this warm-up. So if you go back to 5.4, recall that the derivative of sine x equals to cosine x, and the derivative of cosine x equals to negative sine x. So this is the expectation we have before we continue with this lesson. And again, if you don't remember this, you can always go back, press play, go through the homework before continuing with 5.5. Now, if you look at y equal to 10x, the derivative is going to be secant square x. But if I just told you that, that is not enough. I really want to show you why this is the answer. So again, y prime, not y. And here's the derivation. Now, if you go back to y equal to 10x, this equals to sine x over cosine x. And again, since you can find the derivative using the quotient rule along with the two new concepts from 5.4, here's what happens. When you find y prime, you square the bottom, cosine square x. Step 2, copy the bottom to the top. Step 3, you multiply by the derivative of sine x, which is cosine x, minus. Second last step, you copy the top, and you multiply by the derivative of the bottom, which is negative sine x. Now, y prime equals to cosine square x plus sine square x divided by cos square x. And I hope you call that sine square x plus cos square x equals to 1, which really means 1 divided by cos square x is secant square x. So that's how you can derive the answer. And the shorthand, of course, is if y equals to 10x, y prime is secant square x. Now, just like the last lesson, we're going to show you the same idea, except in the general case. So again, we're going to activate the chain rule in a moment. The moment is here. What is the derivative of y equal to 10 of f of x? So the only difference is y prime equals to secant square f of x times the derivative, which is f prime of x. And again, you can put brackets to separate that. Now, normally, we continue with example 1, but I do want to show you a little bit more. And this is beyond chapter 5 in terms of your textbook. So it's a good idea to learn these skills for the sake of acquiring more skill sets. I'm not saying this is mandatory. I'm simply saying these are additional skill sets that will add value to you. So let's compose this table. Let's begin with the end in mind. So the goal is this. The goal is if I give you these 6 cases, ideally, you should know the final answers on command. So again, the last lesson we talked about y equal to sine x, y equal to cosine x. We just wrote down y equal to 10x, and these are also known as the primary trig ratios. And of course, you can do the reciprocal ones or the secondary ones. And this is when you move on to y equal to cosecant, y equal to secant, and of course, y equal to cotangent. So I will show you how all this makes sense. I'll derive the last 3 with you, even though I'm telling you that with practice, and I hope you really practice this, that once you look at y equal to sine x, you can say, oh, y prime, that's cosine x. When you look at y equal to cosine x, you can say y prime, that's negative sine x. When you look at y equal to 10x, you can say y prime equals to secant square x. Now likewise, and again, these I'll derive with you. I'm just going to show you quickly what the final answer looks like. If y equals to cosecant x, y prime is going to be negative cosecant x, cotangent x. if y equals to secant x, y prime is going to be secant x tan x. And of course, last but not least, if y equals to cotangent x, y prime is going to be negative cosecant x squared. Now, let's show you where they come from. So we're deriving each case for you. This will strengthen your skills for sure. So let's try to do this in this space. Now I'm starting with y equal to cosecant x. Again, you can do this. For sure you can do this. You have what it takes. So y equals to cosecant x. And again, if you think about this, this is 1 over sine x. That's why it's called a reciprocal trig ratio. And again, you can apply the chain rule. You can apply the quotient rule. I am going to use the chain rule because there's no x at the top. So even though a lot of you will go straight to the quotient rule, and if you want to use the quotient rule, that's fine. We'll arrive to the same final answer. The derivative is going to be, you bring the negative to the front, copy sine x to the power of negative 2, and you multiply by the internal derivative, which is cosine x. When you clean this up, you would discover that this is negative cosine x divided by sine square x, which is really sine x times sine x. So I'm breaking this apart into a product of two fractions. I can even put a 1 there. Now, I'm just going to squeeze it in this line. So y prime equals to negative cotangent x cosecant x, just like that. And this is what I wrote down in a summary right there. So done. Let's keep going. Here's the next one. Y equal to secant x. Let's find a spot. Let's do it right here. So again, if y equals to secant x, again, we write this in terms of 1 divided by cosine. Again, we're going to apply the chain rule. This is really cosine x in brackets to the power of negative 1. Y prime equals to, we bring negative 1 to the front. Copy cosine x to the power of negative 2. Don't forget to multiply by the internal derivative, which is negative sine x. Again, when you clean this up, y prime equals to sine x divided by cosine x times cosine x. Notice I'm breaking it apart into two fractions. I can even put a 1 there. So y prime equals to tan x times secant x. And again, we wrote this already. So check mark. One more time. Now I would like you to try this one, of course, and just press play when you're ready. So I'm going to set this up with you. Let's use a different color. Here we go. Now you can do this. There's no reason why you can't. You just got to try. So I'm hoping I'll set this up with you. You're going to try this first. And again, cotangent x is really cosine x divided by sine x. Think about the quotient rule. So press pause. Find the derivative. When you press play again, I will take it up with you. Here we go. So y prime equals to, there's 6 steps. Step 1, I square the denominator. Step 2, I copy the denominator to the top. Step 3, I multiply by the derivative of cosine, which is negative sine x, minus. Second last step, I copy the top. And the final step, I multiply by the derivative of the bottom. So now, y prime equals to, and again, you can factor negative 1 to the front. And in brackets, it's going to be sine square x plus cos square x all over sine square x. And I hope you recognize that sine square x plus cos square x, that's going to be 1. So this is really negative 1 divided by sine square x, which is negative cosecant square x. Again, let's put a box around that. And we wrote this from the table above. So now we've derived the 6 different cases: sine x, cosine x, tan x, cosecant x, secant x, and cotangent x. Now, I'm going to continue this in part 2 with example 1. I hope this makes sense.